Hi everyone, I'm going to be talking a little bit about what the Godot rendering team has been up to over the last couple of years, because I haven't done one of these updates in a couple of years. So first, a little bit about me. I'm the lead rendering maintainer for Godot. I'm also a Godot Foundation board member, and during the day I work for W4 Games. And if you were in the last talk, you know a little bit about what we've been working on. We also do console ports and other commercial support services. So today I'm going to be talking about some new features that have been added in the last few years. There's way too many to talk about, so it's just going to be what I found exciting and what leads to some nice, pretty pictures. I'll also talk about some performance improvements we've done, a general update kind of on the state of development and my personal opinions about the state of the renderer, and then also some of my hopes and dreams for the future. And I say my hopes and dreams because I can't speak for everybody else, nor will I speak to what the foundation's actually going to be putting funding behind, but things that I've thought about and I'm personally really, really excited about. So first, some notable new features in 4.5, 4.6, and 4.7. So first one I want to talk about is specular occlusion. So congratulations, if you're not familiar with rendering terms, you're going to be hearing a lot of jibber jabber like this. I'll do my best to explain what it actually means, but at any rate, I'll show you what it means, and that should be enough. So this is something that was added in Godot 4.5. It's kind of like ambient occlusion, which I hope is a little bit more familiar of a term, or SSAO, that sort of thing. But instead of being applied to diffuse materials, it's applied to reflections. Overall, what it's doing is just reducing lights in areas where there shouldn't be light. So this is kind of how reflections look in most game engines by default. So this is without having GI turned on or like fancy reflections turned on. By default, what's going to happen is you've got an eye, that's the camera, and then you're rendering an object. So that's that orange, orange plane there. And so
what objects look like.
Yeah, exactly. And so what you do is you calculate a reflection, and then you just point to the sky and say, okay, so that's the color I get. And if you have a perfect mirror, and just a perfect mirror in a sky in a scene, that would look good. But typically scenes have objects in them. And so what this would look like in a perfect world is an orange blob, a nice orange blob on your orange mirror. But we don't have access to that information. But what we do have access to is ambient occlusion. What ambient occlusion will do is make that cave look really dark. So what we do is we just apply that instead of applying the reflection, or we actually are tinting the reflection by the amount of ambient occlusion. And what we end up with is kind of like a very dark grayish blue patch instead of a bright blue patch. And that tends to look a lot better. It's totally fake. It's a total hack, but it looks a lot better. So here's a scene, and this was made by Lander VR, who's also the contributor who made the feature. So here, it kind of looks okay, but if you look at the floor towards the wall's getting nice and dark, and then the floor is really bright because it's reflecting the sky through. So we can't actually fix that without using reflection probes or GI or anything. But applying specular occlusion, we can make it look like this, which is a bit more plausible. It definitely feels more real. And if we zoom in on this section here, you can really see the difference, especially if you look in the bucket. There's a lot of light in the bucket and around that little table. The specular occlusion just reduces all of that excess lighting, and it just looks a lot better. Another thing that we worked on, this isn't technically a new feature, but I'm including it because we did so much work on it, but we support Vulkan or D3D12 on Windows. But the quality of the implementation is partially dependent on the quality of GPU drivers. And on Windows, all the companies spend their time on D3D12, and they assume that the only application that would dare to use Vulkan on Windows is Doom. So they test Doom, they make sure Doom works really, really well, and the rest of us are at the mercy of the gods. So what we found is basically every 6 months, either NVIDIA or AMD totally break Godot in their drivers. And then we get a lot of bug reports saying, hey, I've got the latest 5090 or whatever, and Godot doesn't even work at all. How are you guys writing such garbage software? And we're like, we didn't change anything. Like, you just updated your driver, and now it's broken. And so the reality is we basically had to give up on Vulkan because the drivers kept breaking. We don't really have the resources to help the poor driver manufacturers. NVIDIA is a small company. They don't have the resources to maintain this. So we end up having to bite the bullet and just move to D3D12 by default. So it is similar. We already had a D3D12 backend, but the driver support is just so much better, and it's just more stable. And if we can nail down our D3D12 implementation, then things are going to be a lot more stable for Windows users. So why didn't we do this before? Well, tons of bugs. Because Vulkan was the default, we developed everything with Vulkan in mind. We created the D3D12 backend, but there's a very big difference between shipping something that's been tested in the lab and shipping something to a million different devices. So we were afraid of enabling it, and for good reason. We had to do a lot of bug fixes. So there's some more, and there's some more. All of this shipped in Godot 4.6, and fun fact, all of this was one person. And really amazing amount of work done by one person, but it was because the foundation hired our first rendering engineer. So we went from having 0 rendering engineers. Thank you. We went from having 0 rendering engineers to 1, and this is one of the things that he was able to do for 4.6 for us. So basically what we did was, I thought I had a slide on this. Basically what we did is we just enabled D3D12 by default in a development branch, and then we waited for the bug reports to pour in, and as soon as the bug report came in, we fixed it. And we were very, very aggressive about that approach. If you look closely, you can see how close some of these numbers are, because it's like every couple days he was fixing something in certain periods. And now what we hope, and I think what the reality was, is most users didn't notice the difference in 4.6. Nothing changed for them. It just continued to work fine. But our hope is now when the Vulkan drivers break, it's not going to matter because most people will be on D3D12 anyway. And when the Vulkan drivers break, we can just say, sorry, switch to D3D12, and it'll work fine for you. Okay, screen space reflections. This is something that we've supported in Godot for a very long time. And it's always been pretty slow and not super high quality. So I don't know how many people are actually shipping games with it, but it's a nice feature to have, and it's something that we've wanted to improve for a long time. This was overhauled by Scythe, who is that rendering engineer that the foundation hired. So he also did this for 4.6. So he was very, very busy for that release. And the overhaul was able to reduce the cost on my device anyway from just over a millisecond to just over a half a millisecond per frame. Still kind of expensive, but it's getting into the range of being viable to ship on a pretty wide range of devices. So let's look at what that looks like. This is the classic Godot TPS demo with no reflections turned on at all, and I made the road wet. This is what screen space reflections look like in 4.5 or 4.4. I can't even remember now. 4.5. So you can see it adds a little bit, but what really annoys people, if you look up kind of in the top right, it's a bunch more lights appear out of nowhere. That's kind of weird. If you were looking right at the monitor, you'd see a lot of lighting in the back. If you look at those vertical lights, they kind of get all blobby and fuzzy. And then you're just kind of getting this little extra stuff. So paying a millisecond for that kind of feels bad. So this is, so we improved it, and this is what we ended up with. On the projector, this just doesn't look as nice. That's too bad. But you lose you lose those blobby lights that are getting added. You can see the range on the reflections. Actually, here I have arrows to make everything easier. The range on the reflections is quite a bit more. It goes a lot farther. And then you're even starting to reflect small things like this feature, the little reflector strip there, didn't reflect at all before, and now you've got a nice little reflection from it. So then comparing, this is no reflections to now the new screen space reflections. And when I see this, I'm like, okay, yeah, I can pay a half a millisecond for that. I maybe wouldn't have paid a millisecond for the other one, but this looks quite a bit better. Okay, another exciting one is Area Light 3D. This just shipped in Godot 4.7. It's brand new. So what is it? Well, it's a local light, so kind of like a spotlight and an omni light, but instead of being a point that has light coming out of it, it's an area that has light coming out of it. So it's a big rectangle instead of a point. It softens lighting. It's a bit more realistic, but it's very expensive. It's very, very expensive. So right now, we're kind of telling people use it for cinematic lighting or only when targeting like a high preset for high-end GPUs. So this is a spotlight. You have a point of light, and light comes out in a cone. Omni light, you have a point of light. Light comes out in all directions. And then an area light, you have a rectangle of light, and light comes out in a hemisphere from it. So this is what a spotlight looks like. You can see the gizmo even shows you everything comes to a point. An omni light, the gizmo doesn't really show you much, but it is just a single point floating above the ground there. And then that is what an area light looks like. So you get this really nice, soft, and smooth lighting, and it's all been compressed by my slideshow, so you can see all that banding, unfortunately. And then in the hands of an artist, you get something that looks like this. So, you know, if this wasn't convincing to you that this was a nice feature for cinematic games, hopefully this helps convince you. As far as I know, there's no reflection source in this. It's just direct lighting, and it looks really, really quite nice. But it would be pretty expensive on a low-end device, even just to have four lights in there. Okay, and then overall, I'm not going to go through everything in 4.7, but it was really packed with nice features. So we have Area Light 3D, we have drawable textures, were contributed by Colin here. We have HDR output, so that's for HDR screens. We already use HDR internally. We have nearest neighbor scaling, and we have a ray tracing API. We don't actually ship any features that use the ray tracing API, but it's there, and you can use it for your own games if you want to have custom features right now. Okay, so let's talk about performance. Performance is far and above my favorite thing to work on. It's the thing that I am personally most excited about from the last few releases, and I should not touch my shirt. Here are a few things that we did over this is only the last year or so. These are some of the really impactful performance optimizations we did. I'm not even going to read all of these because most of it is going to be jibber jabber, but every single one of these things had a meaningful impact on performance of games. Ultimately, what's not important is, you know, how many things did we do? The ultimate thing is how much faster can games run? Because you can optimize all day, every day, and not make games any faster because you're just optimizing something that has no significant impact on the frame rate, or, you know, only runs once in a while, or runs once in the game and never again. So the important thing is to optimize things that actually impact games' frame rate. So let's look at performance in practice. So I've been using Project Dog Walk recently as an example. This was from the first slide, that beautiful, beautiful looking game. This was made by Blender Studios in Godot as an open project. It's got a wonderful paper mache style with an overhead camera, high quality art. So everything points to this being a great test game for us. But paper mache style, very cool, but surprisingly complex. There's a lot of vertices in there for what ends up being kind of a low poly character. And there's a lot of overlapping transparencies, which is actually really expensive for a real-time renderer. And they have a really low sun angle. So even though they have an overhead camera, you end up getting shadows from anywhere crossing over because shadows are super long, which means you can't take advantage of shadow culling to the same extent. So ultimately, a scene like this ends up being surprisingly expensive. So this is Dog Walk running in Godot 4.4. This is what the version they ended up shipping was Godot 4.4. So you can see here the CPU time, and this is in the editor, it's not doing anything, is 5.3 milliseconds on my device. And the GPU time is 16.6 milliseconds, which works out to exactly 60 FPS, but that's not VSync locked. That's just taking 16 milliseconds to draw this. And that was the state that they shipped with. And so on higher end devices, it was fine, but really it was quite slow. So now this is just literally closing the scene down, and then I reopened it in Godot 4.7. So we've gone now down to 4 milliseconds CPU time and 3.4 milliseconds on the GPU. But this isn't actually what the game looks like. This is just me plopping a camera into the editor. The game actually looks like this. So it's got a much narrower camera, and it's looking down. It's not looking out across the trees. And so let's look at the actual performance improvement in the actual game and not just in the editor. It's nice that the editor is 4 times faster now, but that's not really what we care about. So this is the visual profiler running in Godot 4.4 and in Godot 4.7. Looks surprisingly similar, and as you can see, the difference is only 15% or so in terms of raw performance in the end. And if you zoom in, you can see actually what's happened is somehow the transparent pass has gotten a little bit slower, so that's a massive failure. But the shadows has gotten so much faster that it's just more than made up for the difference in performance. And both the CPU time, which is on the left, and the GPU time, which is on the right, have both basically doubled. And that's where performance benefits coming from in the actual running game. I didn't profile running in the editor, so I don't know exactly what the breakdown looks like there. But here we can see that we won some and we lost some, but the wins were bigger than the losses, so it ends up being okay. Now, normally what you would see in a game is the opaque pass would take up most of your frame time, but there's almost no opaque geometry in that scene. Everything is transparent, so it's the transparent pass. Okay, and then another thing that's really exciting is stability improvements. So it's fixing crashes, it's adding workarounds for buggy drivers, and just fixing overall bugs. So one of the biggest things was D3D12, which I talked about, but also we've had a lot of problems with Android on Vulkan. And if you were in the previous talk, David mentioned that Google wants to get rid of OpenGL. They're really keen on switching to Vulkan only. So for us, having good stability with Vulkan on Android is really important. So what we did for 4.6 as well is we put a lot of effort into fixing all of the weird driver bugs we could find, all of the weird crashes we could find. And unfortunately, there's a lot of buggy drivers out there. This was another huge effort from Skype. So just another reason you can see that hiring one rendering engineer pays off. The difference between 0 and 1 is a lot. So this is a graph from, this is the Google dashboard for the Godot editor on the Google Play Store. So this is crash rates. That's what ANR stands for, application not responding. This is basically the crash rates that we get. And you can see that before we released 4.6, we were averaging 1.52%, and then it's dropped down to somewhere about 0.7. So we cut the crash rate in half, and importantly, we're under 1% now, which is an important threshold on Android. The reality is the Godot editor is very easy to crash because all I have to do is write while true, and then I have an infinite loop, and I will get an ANR error. So it's really easy for users to do things that will result in ANRs. So this number will never, ever reach 0. But we do expect that games that are releasing on Android and using Vulkan will see a similar, cutting in half of their crash rate, unless they're doing things that cause crashes. But the crashes that are our fault have now been cut in half. So we're pretty excited about that. Okay, so let's talk about development generally. So like I said before, I love performance. I love working on performance. And for myself, that has been my focus for the last few years. But as I said before, I'm not hired by the foundation to work on Godot. I have a day job. I have a baby at home. So the actual volume of code that I submit is quite small. So there's lots of work that's going on that isn't in line with my focus, lots of new features that are coming out, but it's kind of lacked direction. It's what people come to the table, like, I really want to work on this, or I feel that this feature is really important, so I'm going to add it. Overall, for the engine, that's great, because most of these people are making games, and they're like, my game needs this feature. Oh, you're not going to add it because you have 0 rendering engineers? Okay, I will add it. And so we get a really nice organic growth in a nice direction, but it's not super, super focused. And so for us, having a rendering engineer means that we can actually tackle the priorities that we've set out on our priorities page on our website. Now, overall, though, performance has improved quite a bit. Some of that is due to other work. David and I were just in the other room talking about a project funded by Meta and a project funded by Google that led to huge performance enhancements for Godot. Some of it is other work that I or others have done just to improve performance for performance sake. That being said, performance has improved in a lot of cases, but we're still not at a point where I would confidently say we can handle massively complex scenes. You can handle complex scenes, you can handle massive scenes, but don't put those two things together because there are fundamental limits to performance in Godot. Coming from things like how we manage VRAM and coming from things like how complex our default shaders are and how fixed our shader pipeline is. So typically, like I said before, the bottleneck is in the opaque pass, but we're also seeing the limits of forward rendering. So forward rendering is a technique where you render an object, and at the time you are rendering that object, you also calculate all the lighting and everything for it. So that's great. In order to make that perform well, you have to first render the object to a depth prepass, we call it, and then you render it again to make sure that you're not calculating lighting for any pixels that aren't visible. That's great, but if you have very detailed meshes, you don't want to draw them twice. And you reach a point where just that cost of having to draw everything twice adds up a lot. So that's what we say when we say you're hitting the limit of forward rendering. It's really just the type of game content that you see a lot doesn't really work well with that method of rendering. So switching to something like deferred render, which is something you might have heard of, would improve that, but it comes with a bunch of other trade-offs that we don't necessarily want to force on people. So we're starting to see those sorts of things, and it really makes us have to evaluate what we want to offer going forward. We don't want to throw the baby out with the bathwater, so it's not like we're going to just completely rewrite the renderer with something else. But we're starting to see that the bottlenecks are shifting, and our ability to optimize things further is going to take more drastic action. Another thing is the 3D workflow is still rough. So for people who are making 3D games, you'd have experienced this. There's a lot of reasons for it, and it's unclear how much we can do just improving the renderer and how much is going to need other things, right? So a lot of the workflow issues come with the way the renderer interacts with other systems. So some of the improvements might mean working more closely with other teams in order to figure out how to smooth things out. Some of it might be making things more automatic, but I think there's a lot of investigation that needs to happen there, and it's complicated workflow things. It's not just adding a fancy rendering algorithm type type thing. I don't think we're at a point where just adding more fancy rendering algorithms is going to make the renderer feel substantially better to most users. I think we're in a place where workflow needs to improve in order to make everything feel better. So what are the workflows issues that I'm seeing? One is our renderer requires a lot of background knowledge, right? I've already thrown out a lot of gibberish about different rendering things, but a lot of times to make your scene look good, you have to understand the fact that you need to enable things like SSAO and glow, and you need to have a world environment node, and you need to configure tone mapping, and you need to have opinions on different tone mapping operators, and you need to know when it makes sense to add a reflection probe versus using lightmap GI versus using voxel GI. And those are a lot of different concepts, and if you balance them all correctly, you can make something that looks really, 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 really good in Godot. But if you're not familiar with any of those concepts, you're not just going to pick that up on the fly. So, some of that can be fixed with documentation. Some of that can be fixed with the community building more stuff, having more demos, having more video tutorials and things like that. And some of that can maybe be fixed within the render itself, but it's unclear. So with all these separate features, we also on our end see a combinatorial explosion. We need to make sure that SDF GI works really well in a scene that's mostly lit by lightmap GI, but then you add SDF GI on top, and then you're also using SSIL or SSAO, but then you switch off SSAO and instead you use SSR. And all of those different combinations have to work. They all have to have decent or acceptable performance and not go off any performance cliffs. So for us, maintaining all of that zoo of features is also difficult. And finally, overall, in my opinion anyway, most assets don't really look good by default, which is a problem. I don't know if it's a solvable problem in Godot 4. Godot 4 is already way better than Godot 3 in this department, where in Godot 3, if you just pulled in a GLTF file, it would just look bad by default until you made changes. Godot 4 looks okay, sometimes looks good, but it usually requires manual tweaking of your lights and your environment and stuff to make things look good. And I think this is an area where we've really broken with the Godot way of doing things. When you make a 2D game, you just drop your stuff in there, you attach scripts, and things look good, right? And in 3D, it takes more knowledge and more effort, and I want that to change. And finally, the light mapper is not as robust as we want. So what that means is the light mapper should be something you add to your scene, you press bake, and it just makes everything look a little bit better or maybe a little bit more realistic. You should have just better lighting everywhere, and that's not the case right now. It's not just a push button to make game look better, and that's what it should be. So there's a lot that can be improved there that I'd like to see improved. Okay, so why are we in this situation? Well, we have 3 renderers. That's a lot to maintain. We have the Forward Plus renderer. It's high end, but it's not super modern anymore. It's like a modern renderer from 8 to 10 years ago. We have the mobile renderer, which is great for high-end mobile devices and iGPUs. It's optimized for those devices, but again, needs to be on something from the last 10 years because it runs on Vulkan, D3D12, and Metal. And then we have the compatibility renderer, which is made for older devices. It's made for web. It's made for low-end devices that don't support Vulkan well. So we have to do all of that, and we have to make sure that we're running things well on web, mobile, and desktop devices. So a lot of permutations there and a lot of different levels of devices, which we may or may not have access to. And we only have one paid rendering engineer. So try to imagine developing new features and maintaining features and optimizing features. I showed how much he was able to do earlier, but it's one person isn't enough to do all of that and keep everything moving forward. Plus, we have to think about backwards compatibility with everything we do, right? So for a lot of game systems, backwards compatibility can be ensured just by having some sort of extra function or extra flag or whatever. With rendering, if you change anything, you're no longer backwards compatible because things look different. And that, to some people, maybe doesn't seem that important, but if you talk to an artist who has just spent 2 days getting something looking just right, and then they upgrade the engine and it looks wrong, it sucks. It really massively sucks, and they hate it. So, we kind of get stuck as rendering engineers because we want to improve things. We want to make things more correct, whatever that means. And we want to make things look better, but every single time we make things look better, we also risk making things look worse. So I have an example here that'll maybe illustrate this. This is somebody, it comes from Bug Report. Somebody wanted to make volumetric clouds using our volumetric fog system. So we allow you to place localized fog volumes that get rendered into our global volumetric fog system. So what they did is they started off something very reasonable. They put a cube in, and they set the color to white, and this is how it looks. So kind of looks like a cloud. If you have a really keen eye, you might see the problem, which is, for some reason, there is a dark ring around the cloud. And if you look at a cloud, it doesn't have a soft, dark ring around it. It should look like this. It should just fade, too far. It should just fade out to white. Okay, so how do we do that? Why is it doing that? Well, we had a bug in our volumetric fog rendering that was multiplying the color of the fog by the density of the fog, and that was making it get dark because the density at the edges is very light. Okay, makes sense. Mathematically, that's wrong. Doesn't align with how volumetric fog is supposed to work. This is obviously an improvement, so let's make that change. And, now that we've made the change, let's look at how it looks in an actual Godot scene, not just in a little bug report. Okay. That doesn't make a lot of sense. All we did was fix a bug. Why is this happening? Well, just take a look at the settings in the project and figure out what's going on. So here's the spotlight on the left. Something wrong here. Oh, no. Oh, no. Why is this happening? This light, while calculating volumetric fog, has a brightness of 95,000. Now, by default, a light in Godot has a brightness of 1. This is an extra bright light, so it has a brightness of 24. And when calculating volumetric fog, it has a brightness of 95,000, which is just way out of whack. But it was necessary to do that before because Godot was multiplying the density of the fog by the color. So if you wanted your lights to show up and not just be a black blob, you had to increase the brightness by a factor of 1,000 because the density of the fog there is about 1/1,000. So everything, if anyone wanted nice looking light, here I'll go back, nice looking kind of light rays and stuff in here, they needed to increase the thing by 5,000. So it turns out a lot of people had done this so that their games looked okay. And once they opened their game in Godot 4.6, it looked like this. So ultimately, in this case, what we had to do is introduce a project setting that says use legacy blend settings. And whenever somebody complains that their game now looks like this, we just say, go and tick that on. But every time you make a change to improve things, you end up doing stuff like that. And that adds more complexity. And now that setting is something we're going to maintain for all of Godot 4, and we're not going to get rid of it until Godot 5. And we don't know how long that's going to be. So it's more complexity for the engine that we have to maintain just to make sure that that behavior stays the same for people who are upgrading. Okay, so how do I see new features coming out? That was a lot of doom and gloom there. But the end of the day is we do want new features and we do want to improve. What I'd like to see first is new features that are focused on making users' lives easier. So that includes performance improvements, workflow improvements, and things that make your game look better without a whole lot of added effort. I don't see us adding in huge new systems that require a lot of learning and don't work with our existing systems. I'd rather see incremental improvements to everything. So like SSR. Before it wasn't super viable, it didn't look super good. Now it looks great, it's way cheaper, and it's something that has become more viable for a wider range of projects. I don't expect we're going to overhaul the Forward Plus renderer anytime soon. Basically, it's going to be architecturally mostly the same. We will make some improvements. Some of them will be large, but from a user perspective, it should mostly stay the same, just with new features added on top. I'd really like to see improved feature parity on the compatibility renderer and the mobile renderer. The mobile renderer can have almost all the same features as the Forward Plus renderer. They just need to be implemented in ways that are optimized for mobile. So that's something we can do. It's not impossible. It's just a resourcing problem. So that's something I'd like to see happen. Compatibility renderer maybe can't quite support as many features, but there's a lot of features that it doesn't support that it can. So we'd like to see that happen too. So overall, we want to enhance the experience for existing users without increasing the maintenance burden or the surface area of the renderers by too much, because at this point we don't really have the capacity to keep expanding it. So we're going to focus more inward and make sure that what's there is rock solid. So this is my hopes and dreams for the renderer. So I want to see more performance with the existing content. As I was showing earlier, that's happening, and I want to see it continue. I want to see more stability across all platforms. We've done a great job recently making Android more stable, but we support a lot of other platforms, so there's a lot more work to be done there. I want to see more community knowledge about the renderer grow, and this is another problem with backwards compatibility. If you change things too much, then everyone's tutorials are out of date. Everything made by content creators on blogs and YouTube and everything becomes out of date. So I want to see this knowledge grow, which means we need to give it space to grow. I want to see fewer breaking changes to the renderer. I don't know how feasible that is. Fewer overhauls of core systems, which is something we were doing a lot in earlier Godot releases. Really up until about Godot 5, we were making huge changes to the renderer every release. And Godot 4.5, sorry. And I want to see that slowing down. And ultimately, that'll come with the rate of new features slowing down. And finally, I want to see an increase in the plugin and extension ecosystem. There's a lot more hooks we can expose in the renderer to allow more people to do more custom things, ship those things on the new asset store. And that's something that I see as a very important next step for the renderer. So that'd be more flexibility with custom plugins and extensions. Now in the far future, this is me like what I dream about at night. I want to see just two renderers. One is just drop OpenGL support entirely. So we don't have to support 3 different renderers with tons of different stuff. Have a low-end renderer. It's made for mobile devices. It's optimized for low bandwidth. It's optimized for VR and those sorts of things. And then a high-end renderer that just uses path tracing for everything in hardware. So the beauty of something like that is it's so much simpler to just path trace everything than to have SSIO, SSIL, SSGI, SSR, SDFGI, voxel GI, everything, and blend all these things together. All you have to do is say, I've got a beam of light. I'm going to simulate that beam of light bouncing around the scene, and eventually it gets to my eye. And what does that look like? Oh, wow, that's how reality works, and it actually looks good. If we can make that fast enough to run it real time and ship that on a wide enough range of devices, that's all we have to do. We don't have to be combining all of this zoo of things. We can just have one thing. So the idea that I would love is to have something like that, really simple, and avoid all of these kind of super, super complicated techniques that are hard to maintain, that are hard to make work with other systems, and just have one thing. And then the low-end renderer would still have to be rasterized, but the idea would be to structure it, instead of having a zoo of features, have more unified features that you turn on and things just look good. So in both cases, we'd have a unified lighting workflow. Because the reality is, everything we're doing in a rasterizer, tens of thousands of lines of code, we're just trying to mimic what a path tracer does by default. And it's just how it works. It's the reason that animation has all moved to path tracing. It's just simpler and better. It just costs, by default 1,000 times more than rasterizing. So the trick is doing this once there's a high enough range of devices that can do it. And right now, if you've got a modern NVIDIA GPU, you can use path tracing. Cyberpunk 2077, it's a very complex game, and they shipped with path tracing years ago now, and it's becoming viable. But those are my hopes and dreams. There's a reality behind this. OpenGL isn't going anywhere. It's still needed for the web. Web GPU is slowly gaining adoption, but it's been quite a bit slower than we expected. If you asked me 3 years ago, I would say that web GPU would be everywhere by now, and it's not. So, and I wouldn't even guess now when we will have broad adoption of web GPU. So we're probably stuck with OpenGL for many, many, many more years. Hardware ray tracing support's only fast enough on really high-end devices. That seemed like not a big deal last year because GPUs were getting better and maybe not cheaper, but better every year. But that's not so true anymore. The current expectation is that the next generation of GPUs won't really be a huge step up over the current, or won't be a step up at all, and the prices aren't going down. So, we don't know if in 5 years it'll actually be feasible, or 2 years, or 3 years. So then the other thing is we want people to be able to continue upgrading. So at what point do we pull the trigger and do something completely different? And again, make people learn a new system, make content creators rewrite all of their tutorials and things like that. The beauty, or it's a double-edged sword. Godot has become very popular. Every time we release a version of the engine, it gets downloaded millions of times. But that means that every single time you break compatibility, the cost is higher and higher and higher. So is there a point where it's going to be worth it for us to throw out all of that collective knowledge, throw out all of that collective experience in order to make something that I personally think is better? I don't know. So that's the reality. I'll keep dreaming and we'll see what happens, but I'm not sure what we'll see out of that. Okay, thank you. Thank you very much for listening. And I think we have time for questions.
Yep, about 7 minutes.
7 minutes, okay. I think we've got a mic there. If anyone has a question, you can stand up and ask it, and I will stay here for 7 minutes.
I can bring it to you as well. Or people will feel comfortable projecting. Hello?
Well, I can project.
There we go.
Okay. I disagree with the dream that path tracing is ultimately like the future, because I'm not sure how path tracing lives in a world of stylized rendering techniques. If all you're doing is realistic, it's great, but most games aren't that realistic.
Yeah, that's a good concern. So the reality is right now in Godot, if you make your assets and use it in Godot, we use a physically based renderer, and everything is designed to look as closely to path tracing as possible. So all of the same knobs and levers that you currently have to do stylized rendering would look the same. And it would functionally work the same. There are limitations in going with a full physically based rendering pipeline, but the reality is people are making great non-physically based stuff now by tweaking material settings. And if we use a path tracer, you're going to have the same material settings, and you'll use the exact same tweaks, and they'll look very surprisingly similar to the way things are now, but you'll just have the benefits of proper indirect lighting and things like that. there are techniques that have been lost because we've all moved to physically based rendering, but that's a ship that sailed 15 years ago. We're already taken on all that problem. So the point is, if you're happy with the way things are today, then you'll be happy. If you want to go back to the way things were 15 years ago, then yes, path tracing will make things harder. But that'll just be the reality of things.
I'm one of the people that tripped over the fog bug.
Okay.
Thanks for fixing it.
Fixing.
Well, no, it is fixed. And the question I was going to ask is, or maybe a thing to suggest is batching groups of things that are breaking changes together and putting them under a group of compatibility flags. Instead of having like little piecemeal pieces, will reduce the overall complexity and make my life easier. Because I can decide when I want to move forward to whatever the new set of fixes are, go back and update all my things and update my math. Is this something that you've talked about in the org, batching this stuff?
No, actually, it's funny because I think it's a great idea, first of all. We've never talked about it because our hope has been that we never have to have these compatibility flags. And if you spend a lot of time on GitHub, you'll see I'm pretty aggressive about that too. There are a lot of times where people will add a compatibility flag for something, and I'll be like, are you sure it's needed? And I'm always the one pushing back, being like, we need to absolutely minimize the use of a flag. So my gut feeling is we either need to have a fully standardized system where we do something like that, we keep the complexity to a minimum, and we have a system where people can bundle things in, or we need to be super aggressive and just not let people break compatibility to the extent that we can.
Both of those things.
Well, if we have something that's really easy, then people are going to be like, oh, okay, I'll just use that. I'll just add it into this, and what we'd rather see is just not breaking compatibility. So if you give somebody the tools to shoot themselves in the foot, they will do it. We might not be able to avoid it, right? And if we can't avoid it, then I think what you're describing sounds amazing because it's, it minimizes the complexity while still giving tools to people to maintain things. I'm just hoping we can get away without doing that is really all it is. But I think that's a great idea, and it's not something we've discussed. So that's definitely something that'll enter the equation
I have
now.
more thoughts on it, but I'll for it.
Okay. Thank you very much.
A big problem is that it's also largely guns points at other people's feet is the biggest problem.
Yes.
Any other questions? I'll bring the mic around for us.
So you mentioned a little bit about using GD extensions to extend the renderer as it is currently. Are those hooks something that is currently available in the API, or is that something that's upcoming changes?
Some are, some aren't. So right now you can use the compositor effects API to insert render passes between the built-in render passes. So you can do post-processing in there or mid-processing. We want to have more hooks to do more things. So one that I foresee hopefully happening in the next year or so is having hooks to bring your own upscaler. We can't ship out of the box with like DLSS or XESS or FSR4 or some of the other newer ones, the Snapdragon upscaler, ARMS upscaler, things like that, because they're all shipping with non-MIT code. The SDKs typically have like an open API, but the SDKs are closed. So what I would love to see is being able to do that, but then for other features too, right? You should be able to drop in other sorts of rendering features and then have them apply to everything. So we have some ideas for other hooks, but not like other than upscalers, nothing's in the works yet.
And another question, just web GPU question mark? Is it up in the air? It's
We'll see.
we'll see.
It's so from a foundation perspective, it's very hard for us to invest in a technology that is not supported on Linux, right? We're a multi-platform engine. This is something that if it works, the benefit would be that it works everywhere, and the fact that it's supposed to be a web standard that's supported everywhere and it's not supported everywhere means we're waiting. Once it is better supported everywhere, then we'll put resources into it. But there is a number of community efforts to making a web GPU backend. There was a talk yesterday about building a web GPU backend, and there's another person out there who's in parallel working on their own web GPU backend. So if either of those efforts become viable to include in the engine, we might see adoption earlier. Otherwise, we might just be waiting until web GPU is more broadly supported.
Awesome. I think we have time for one more question. Anyone? Okay, well, thank you so much. Oh, you go. You are our last one.
I know that you hate the idea of adding a fourth rendering engine, but is it possible to add a fourth rendering engine to do the path tracing?
So anything's possible with enough resources.
Yeah, I'm just wondering, but it
Like-
doesn't break this.
From a technological standpoint, we actually designed Godot 4 in such a way that we could easily drop in another renderer. And there are certain architectural decisions that look very awkward right now because it's designed around having a fourth renderer that is all GPU based. So that could be a path traced renderer or it could be a fully GPU driven renderer. The scaffolding is all there and it's currently unused. So technology wise, absolutely. Can we maintain a fourth renderer on our current resources? Not really. So it's a resourcing question.
Okay.
Yep. Okay. Thanks everybody for attending.